There's the PicoRoach, pretty much done there, and we can turn it on and watch it go. There it goes, turn it around. Hi, I'm Phil from PicoKit, and today we're going to look at how to make the PicoRoach. A couple things to point out is that the PicoRoach is the new version 2, and we are now using acrylic, and we are using acrylic linkages. So instead of using wire, it will be much easier to assemble. And a couple of other points, there are now no pop rivets, so it's easier to connect together with screws. And everything fits a whole lot nicer. So you're going to find that this is a much easier, more enjoyable project to do. We'll just go through the new components. So first of all, the acrylic components here, all together, nice and easy to pop out, much smoother on the edges than the old polycarbonate. They fit much nicer, and everything moves a whole lot freer. You'll see that we've got these antennas up here, plastic antennas, and you can use a bit of super glue for those, which is a lot easier than bending and twisting any of the wire. Now, just from the left, we've got the 3 servo motors, so they're pretty much the same. We've got these rubber bands. Now there's 4 rubber bands for 4 of the feet, the 4 feet that needs a grip, and we're using rubber bands now instead of the rubber feet that we used to have. So rubber bands are a lot easier to use, and they don't have black powder on them, which was one of the complaints, was that it was a bit messy. So we've still got a couple of micro switches, and instead of putting those micro switches on with pop rivets, we'll be using some screws. So we've got 6 of these screws at that size. They're the mid-size screws. Other screws, we've got the 6 miniature screws, and we've got 4 of these large screws. Other electrical components, we've got the 5-volt regulator, which gets hot a bit, so don't touch that one while it's running. We've got the microchip, which is pre-programmed. You can also program this kit via the PicoFlow Alpha software. That's a PicoFlow Alpha programmer, which you might have purchased so that you can use the PicoFlow Alpha software. So we also have the IC socket. So the IC socket stops the heat getting transferred and burning out the microchip. We've got the switch, on-off switch. We've got, at the back here, we've got 3 3-pin headers, straight pin headers. We've got 2 105 capacitors. Now, if your pack has 2 225 capacitors, that's fine as well. They'll just be drop-in replacements. We've got the programming socket, which is a 4-pole connector. We've got the 9-volt battery snap, and we've got some resistors. So down here we've got 3 330 ohm resistors, 2 10k resistors, and a single 1 ohm resistor down there. That's all the components that you need. Now, as I said, you will need a bit of super glue, and some of the other things that you might need a dab of blue tack, and you might need a 9-volt battery. You will need a 9-volt battery. Some of the tools you might be using a soldering iron. This is a 30-watt soldering iron. You might also be using a soldering iron stand, and this is one of our new stands at PicoKit, soldering iron stand, which is very handy. And something like a helping hands, we found these are a lot better than helping hands, is a PCB soldering shelf. So I'll be using that today. And some of the other things, you might need a solder sucker if you've put components in wrong. And you might also need some solder. You will need solder. And you might also need a couple of screwdrivers. Okay. Now, before we get started with the PCB, it's important to note that all of these parts made of acrylic have paper on them, and you'll need to peel off the paper. Please do not join any of these parts to the board with paper still on them. The paper has a thickness and it will change the way that the parts move and move freely. So you'll notice that some of the paper is a bit burnt as well. It doesn't affect the product at all. So I'm just going to go and peel off some of this paper so you can see what to do. That is all of the paper peeled, and just to check we've got all the bits, we've got 4 of the outer legs, 1 of the central dual legs, we've got 2 of the long linkages, we've got 2 antennas, we've got the little mounting brackets for the center servo, top and bottom. And we have 2 small linkages or levers for 2 of the servos, and we also have 4 of the pivots, the central pivots. Let's push that aside. With our helping hands, first of all, it's important to set up the helping hands the right way, or soldering shelf, as it's called, PCB soldering shelf. Instead of mounting our circuit board this way, we're going to turn our circuit board this way because it's easier to clip onto the sides of this circuit board, or you can clip on the narrow edges as well. So we basically push those 2 together. I might do it long ways. It does get a better grip when you do it long ways. So put that in there, and we put a bit of pressure on so that this spring collapses or squashes up just a little bit. So this little end, this stop out here, presses out, and then we tighten up the nut down here, and that will lock it in place. Now, if you do need to take it out of the circuit, you can always compress that spring further, and it will slip straight out of there. Okay, so we're going to start by putting on the resistors. What we want to do first of all is pull off the bits of paper off of the resistors, and then we just pinch a resistor between our fingers, and with our other finger we bend it down at 90 degrees. Put it in the other hand and do the same in the other direction. We should be able to get those legs fairly parallel to each other. Now, it is quite important that you bend nice and close, the way the circuit board's been designed, and it doesn't matter which way the resistor goes, as long as you get the right value. So this is a 1 ohm resistor with the brown, black, gold bands, and then an extra gold tolerance value. So brown is the number 1, black is the number 0, so you'd think 10, but gold is the multiplier, and gold means it's actually divided by 10, okay, or 0.1 of that 10 value, which takes it to 1 ohm. And so we put it in the 1 ohm location, and we can push that down, and we can bend out those legs at the back. And I'll turn that over just so you can see how I've bent those legs. Really, we can go and do all of the resistors at the same time. So we'll do the 10K. So there's 2 10K resistors, and the color bands on the 10K is brown for the number 1, black for the number 0, and the third band is orange, which is 3 extra zeros. So 10 plus an extra 3 zeros is 10,000, or 10K. So we can bend that again by pinching and bending those over, and we can put those in the 10K position. Push it down firmly so it sits nice and flat, and then with your fingers at the back you can bend those over. Not too far, about 45 degrees is what I normally do resistors at, just to hold those in place. Third resistor, bend that over. Now I do like to always put the tolerance band on the right hand side, so or above the whatever the letter is, if it's a K or an R, and the tolerance on these carbon resistors is gold, so that's a plus minus 5% tolerance. There's a second 10K, and we can bend those over. Okay, so we haven't done any soldering yet, but we can place all the resistors, that's fine. So let's get our 330 ohm, 330R resistors, and bend the legs, so pinch, push over at 90 degrees, pinch, push over 90 degrees, and place in the holes. Push down and bend resistor legs. 2 more to go. Bend at 90 degrees, bend at 90 degrees. And once again, putting the tolerance factor over the letter R. Not really a concern if the resistor goes in backwards. Resistors are non-polarized, so I'll just do it by matter of convention, so the circuit board looks neat and tidy by having all of the resistors in the same direction as each other. So I'm just bending those over again, and now I've got all of those resistors in. It's probably a good time to do some soldering. Okay, the soldering iron should be hot now, so I'm just going to come in here from the side with the soldering iron, and what I like to do is lie it down on its side, rest it on the pad so it heats up, and I just pop in a bit of solder. And so you can see that that has just put solder on there. If we get a close look, yeah, it's covered the pad. It might work from this side actually. So I've got those two, and there's another one from there. So those 3 soldered. If I just turn that at a different angle, maybe you'll be able to get a good look at those. Let's do the other ones up here now. Oh. Now, a bit of safety with soldering. It's okay to use a lead solder, and actually lead solder is the best thing for the tips of these soldering irons. Unless you have a particular lead-free tip, it will eat away at the solder. Leaded solder doesn't spit as much, although it's a good idea to wear safety glasses when you are soldering anyway. And so there's lots of benefits to leaded solder. It melts at a lower temperature, so it's easier to solder, flows better. You can get flux in both leaded and lead-free solder, but one of the problems with higher temperature lead-free solder is that you don't get a nice wetted solder joint, so you will quite often get a dry solder joint, characteristic of non-shiny solders. So these are all nice and shiny because of the lead in the solder. Now you can touch lead solder, just don't eat it. If it's going to poison you, it will poison you by ingestion, which means it gets in your mouth. So certainly don't eat food while you're soldering. Don't eat food after you're soldering unless you have washed your hands. And you'll see the smoke come off. The smoke as you're soldering is not a problem with lead. It's only a problem with the resin or rosin inside, which comes from a pine tree, is known to have problems in causing asthma and different types of respiratory issues. Now you'll see I'm cutting off these. okay, with side cutters, so flush mounted angled side cutters, flush cut side cutters, and you'll notice I'm holding the wire, the extra lead, and I'm going down just above the little cone of solder, and then I'm removing that wire from its place and snip, removing the wire and putting the wire in a safe place so I can dispose of it in the bin. Last thing you want to do is drop these wires on the floor and have them become like needles to unsuspecting victims. Okay, so it's not very nice if you drop needles on the floor. People will stand on them if they're not wearing shoes, and then all sorts of problems can happen. Okay, so you can see those resistors are soldered in place, and we do resistors first because they're the smallest component. Keep the resistor leads because we need them here to put for the micro switches. So there's our resistors, nicely lined up, and some of the small components we'll do. We'll use the programming socket. Okay, so if I can line that up, programming socket. And what I do with the programming socket, although you probably can't see it if I lift it up, I do bend over the pins on the back, and to do that I'm actually going to take it out, and I'll just do it here. So holding that in place, get that in place, you can see it's got 4 pins, one here and 3 down the bottom here. So I just use the side cutters and I just bend those over a little bit so that that back one is actually ground pin. Oh, I can get it to bend over. There we go. And do one more just for. Yeah, I'll just do that one. There. Okay, so 2 of those bent over, and that'll be enough to hold that in place. It does wriggle around a bit. Now, one of the things about these components here, if you are going to be programming the PicoRoach, it is a good idea to shove something in that hole while you're soldering it, because nylon melts at about 250 degrees and these soldering irons can be up to about 400 degrees. So if the plastic melts, then the pins are going to shift. So what I like to do is grab one of the cables from the USB programmer, clip that in place so it's sitting nicely. It should turn freely. And that will stop the pins from moving out of alignment. So I can keep that in place. Now I can solder off those. Now what I like to do is I like to make sure that all the components sit flush on the circuit board. So I'll solder that back one. And what I'll do is I'll apply a bit of pressure, and I'll actually reflow that solder, and with my finger at the back here, I'll just lift it up. My finger at the back, I'm actually putting pressure on that so that it sits nice and flat on the circuit board. Now I just do that for one. If I did it for these other pins here, I'd burn myself, because the ground one is the only one that's not touched. It doesn't come through to the roof of that socket. So if you're reflowing this pin here and your finger is on the back, you're going to burn it. So just do it for that ground pin. And like I said, this rosin can be a problem. I don't have extraction running here. I probably should. It's a bit far away from me at the moment. But I normally just blow away the smoke anyway. But I am in a bit of a confined space, so I might just turn that on. And at least that'll clean a bit of the air. Having an exhaust. It's not an exhaust as such, it's a filter. So it's got a carbon filter sheet, and I'd show it to you, but I'm zoomed in, so I won't. Okay, that's the socket. I can take out the cable there. Actually, it's nice to test it. Yep, that clips in, that turns freely. It's if it doesn't turn freely, it's going to scratch. And that's why we do that. That's why we plug that cable in. Look, it's not going to change the alignment of these. These cables seem to withstand the heat quite well. So there's no problem in plugging that in. I've had people use 2.5mm nails. Please check that the nail is actually 2.5mm, because I know on some nails, or most nails, they have like a bit of ribbing on the end of the nail, and that goes outside of 2.5mm, which could be a problem when you're trying to program and it's too loose. Okay, so it is actually best to do that with the cable, the programming cable, that one. Okay, best to do it with the programming cable. Now we've got that in place. Let's put in some more components. So I'll put that down there. Okay, so some small components that we might put in. The capacitors, and like I said earlier, these are 105 capacitors. Okay, a 105 is a 1 millifarad. And we should be able to line those pins up with these capacitors. They're actually monolithic capacitors. So I put that in. Doesn't matter which way they go. There's no polarity on these. I'm going to cover that with my finger and bend the pins at the back. They're a little bit sharp, a little bit stiff, but you can do it. Okay, so that's one in place. I'll get the next one. Line that up, and once again you get a nice picture of my lovely fingernail. There it is. You can see I've got those in there, and I'm just bending that over just to hold it in place. So the reason we try and get those components closest to the board, if they're further away from the board, they run the risk of being pushed over, levered over, which can mechanically break the joint of the solder to the pad, or it can cause a hairline fracture, intermittent faults. So you do need all your resistors and your capacitors and everything like that sitting as close to the board as possible. In industry, sometimes they'll put a bit of a dab of silicon or glue or hot glue or something like that to hold those in place to give them an extra mechanical strength. So I'll just solder those. So please note, when soldering, maybe I should have said this earlier, heat up one side and actually put the solder onto the pad on the opposite side, and you get the best soldered joint. These are only 30-watt soldering irons, but you can see they're working quite well. Now these are a little bit harder to clip off. I just put my thumb over the top and snip. And the reason I do that is because these become projectiles, and you can shoot yourself in the eye, or you can shoot someone else in the eye. And also, as I said, to stop them getting on the floor. So, but you can see those are soldered in place. Now, next, let's put in the socket, IC socket. Okay, with the IC socket, it does have a polarity, and you can see by this little notch in the side of the IC socket, and that should line up with the notch on the silk screen symbol of the component. And you have to make sure that the the leads or legs of the IC socket are nice and straight and parallel. Okay, so you should see that they're nice and parallel. If not, straighten them. You need to make sure that all 8 of those leads go through the holes. If any of those pins pop out, you have to push them back in. Okay, that's not going to hurt it. It's just metal pins in a plastic part. So I'll just flip that over. We've got all 8 pins sticking through. Check that, that's fine. I like to use my side cutters and bend over diagonally opposite corners, which will hold that in place. And we can heat up and apply solder to each of those pins. so. Okay, so they're looking pretty good. Don't need to trim those down. Okay, so let's flip that over and we'll just slide that down in there. It's getting a bit tight. Okay, so we've only got a couple more components up here to do. 5-volt regulator, and so this will cut the 9 volts of the battery down to 5 volts. One thing you have to be careful of is heat. I've said that. It says it on the circuit board, hot, 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 hot. Okay, so basically these things have to dissipate 4 volts. 9 volts down to 5 volts, 4 volts difference, and dissipating 4 volts makes them quite hot. This is 7805T. Okay, now to put this in place, we do want it to sit nice and flat on there. It is made so that part of the board there will dissipate some heat through the board. I'm just going to show you that you can bend these pins over, but if we bend over the pins, we actually want to do it in 2 stages. So we have basically a 45-degree angle and then out at 90 degrees. So I'll do that, get that in there, apply some pressure. It's quite a bit of pressure, and I'll actually bend just a little bit past it just to get those in place. I'll put that up here. See that they fit in nicely. Look at that, perfect. Okay, so so that's the 5-volt regulator. Those pins are just the right size to actually hold it in place without needing to bend them over. So that's pretty good. So I won't bother bending them over. They're a bit too thick anyway. So it's 1, 2, 3. So so that's the regulator soldered in place. Now I'm going to cut this direction, not this direction. Why do you think that is? Well, the pins are wider in this direction. They're wider and thinner. And if I put too much pressure on these, it's going to put dents in those, and they don't work when they've got dents in them. So so it is definitely best to go so that you're going in line with the thickest, longest section, if that makes sense, of the pin. And I'm just going to hold that and trim it, and you'll see it trims nice and easy. If I go the other way, it trims easy, but it does put dents in your side cutters, so you don't want that. Okay, so that's the regulator in place. Now you can see there's silver on this side, but that doesn't really mean anything. In the past, I've put a screw in there, not really necessary. We could solder it down actually to join it to the board. I can show you that. So from this side, from the top, you'll see it just a little bit. Okay, so you can see that the board is there. I can actually get some solder on that little edge in there. And we'll just see. Oh, this is a test. There we go. Well, it looks a bit messy, but that does give it a bit of a connection to the board to allow the heat to go through the board, just to give it a bit of area to spread out the heat, so it's not all concentrated. Sometimes you can leave those sitting up, but if it's sitting up, you're more likely to touch it and burn yourself. So I fold it down. It's not going to be a problem to the board. Now, the last thing we need up here is our switch. And it doesn't matter which way the switch goes, we just place that in, and we can turn that over, move it down so we can see it. There it is. Okay, so 3 pins sticking through. Now I can bend those over. I'm going to bend those over sideways, but I'm putting a lot of pressure on the back here to hold it in place. So I'll bend one that way. making sure that I'm forcing it sideways. There we go. And I'll bend one the other way. Okay, so if I bend them in the same way, it might still fall out. So I'll just bend them, and I may as well stick this one down too. Why not? Why not? Okay, so that's going to hold it in place. Now we'll solder those off, like so. Bit of solder in there, bit of solder in there, and a bit of solder. Now it doesn't matter what the orientation of that switch is. Oh, looks like I need a little bit more up here. There it goes. Okay, so that's switch in, and the last thing we need to do is the 9-volt battery clip, apart from some pin headers that we'll look at later on. So, so let's turn that around. We'll have a look at this. There it is. Okay, so so basically you can see up here, up the top, we've got power and ground. We want to get our red and black wires down into the power and ground. Now, if we're coming down from the top, we actually want to make sure that we go down through the hole. And these are done so that both wires fit through one hole. Okay, so both wires go down. We put enough through that it gives us plenty of slack on the other side. And I'm not going to spin it over for this. I'm just going to try and line it up. And we put both of those wires back up through the second hole. Okay, so I hope that makes sense. Pull it up enough, not the whole way, just enough to bend it, force it back down, and we put the red wire through power, PWR, which is, when we put it through, we can line that up, push it through, so it's sitting down there. You can bend it over at the back just to hold it in place. And I'll do the same with ground. Try not to get my head in the way again, but it's hard to see. I'm so far away. Okay, so I've just pushed that in, and I might turn it over. I'll bend it over a little bit, but I'll adjust those. Okay, so we've got a loop on the back here, and we've got our two wires, and you'll see I've bent one way and I've bent one the other way, just so that they don't touch together. And so now I'll solder those off without touching the plastic wires. So we certainly don't want to touch those plastic wires. And you'll see that wasn't too hard. Now, the reason we leave a loop there is so we can pull it back. So, so now that it's soldered, I'm going to pull this back. Oh, which way? I'm just going to take it out for the moment. Okay, so so we've got the wires going down through the first hole, underneath, up through the second hole, and then down into the respective pins. So we want to push this loop back, or we can pull it from underneath. Pull that. Come on. I'll just pull one at a time. It's getting stuck. Okay, so there it is. Pull on that wire. There it goes. And pull on this wire. Okay, so they're pulled in nice and tight. And we can do the same for this one. Pull it in nice and tight. Okay, I like to pinch that wire and twist. Okay, twist gives a more professional sort of a finish. We twist those up, and you'll see I'm doing all the twisting here. Twist, twist, twist. And as we twist it, they will join together, which is pretty cool. So you don't have wires hanging all over the place. And if you let it go, it untwists a little bit, but it keeps its same form. So, so that's pretty cool. So I'm just going to wrap it around, and around like that, where I know it shouldn't get in the way too much. The way it is there now, I can actually put in the microchip. So I'll show you that. So this is the microchip. It's got 8 pins on it to go in the 8 pins of the IC socket. And you'll see the notch on this side, this one here. And the notch should match up with the notch on the PIC microcontroller. And if you need to, you might have to spring those legs together so that they're parallel, just with a bit of compression. Or what I do when I put it in is I'll tip it up on an angle. So it's hard to see from that angle. Let's turn it around. Tip it up on an angle like that. And I put some pressure on just to line those pins up. Once it's in place, push it down so that it goes in place like that. So like I said, we can wrap that cable around there, and we've still got extra. Might get some hot glue and glue that down in place after we know that we've got space. So I won't worry about that at the moment. That's something we can fix up later. Okay, so so that's pretty much most of the circuitry done in here. Mind you, we do have to put some micro switches up here, but we've got to put the plastic on. And same on this side, we've got to put some motors in here, but we need the plastic up here. So let's have a look at how this is going to happen. So the top of the circuit board is this side. This is the top. So we want the center leg, which is this one with the 2 legs. That's going to rock backwards and forwards. We want those legs to go down. If you put them up that way, that's going to be a bit of a problem. So just make sure you do it the right way. Okay, now the servo will fit. It will fit in both ways, but you might find that it fits better in one way more than the other. Now I didn't push that right in because it is going to grip pretty well. Which way? Okay, so it doesn't fit as well that way. So certainly I want to make sure that this motor is going behind. So I'll just put that in for demonstration purposes. When we put it in, it's better to put the leg that way because the servo will fit in that gap up there. If I put the plastic on the other side, it may not fit on the servo. Okay, so so I need to put it on that way. If I hold it still, that's the way I need to put it. So I can take out that servo because that's going to go on there and sit on there like that. And this leg is designed to rock backwards and forwards. And I will do that with this little servo. Before we put the servos in, and we've got that in place, we need to do some more soldering. Because it's important that we get these little pin headers in the right place on our circuit board. Okay. Now this is probably one of the hardest parts to do because the pin headers don't like being bent over at the back, and they certainly like to fall out. We've got to make sure that we also get the pin header the right way. Don't put the pin header in underneath the board. Okay. So we actually want to put the pin headers on top of the board on the same side as all the rest of those components. And we might want to do one at a time. So I'll put this back in my mopping hands. And this is where your blue tack might come in handy. Now, actually, I'll take it out and show you. I'm going to put the blue tack on there to hold one of those pins in place. But if I solder that pin, this blue tack's going to turn to melted, yucky blue tack and stick everywhere. So I want to make sure that I just hold the pin in and solder just one of those pins off, the one that is not touching the blue tack. Important, do not melt the blue tack. Okay, we don't want to wreck your job by melting the blue tack. So I'll put this one, heat this one up, put the solder in here. Got it in place, that's going to hold, and I can now take the blue tack off like that, and I can solder the other 2 pins. Okay, so that is the hard bits. Now, if I've already got it this way, you might be tricky enough to do what I'm about to do and to put it in from the back, because I know that's where it's going to go, in there, and I know I want my blue tack on that top pin. Squash it in there. That's in place. Get the solder in the right place, heat her up, and there it goes. That's one. Take the blue tack off, and we can solder the other two in. I said this was the hardest part, didn't I? But it's not if you follow this process. Okay, so the last one here, I'll make sure I know which side the blue tack. I'll put the blue tack on the dot side. Okay, blue tack's going to hold the dot side, solder the non-dot side. Get that in there. Come over the top and... Okay, so what if you solder these on before you've put in that plastic leg? Well, I'm sorry, you have to unsolder them. And I could show you that. Maybe I'll show you that. And then I'll just press rewind. But to get those pins back out, you actually just have to heat them all up. So I can actually just run that over there, and I'll pull that up. And those pins will pop out. Get some pliers on that. If you heat up all three pins at the same time, you'll notice actually one of those pins is falling out in the center. It's a bit longer than all the others. Not a good idea to stuff it up, because you might find that you're going to have a problem later on. So let's press rewind. If you do have that, I'm going to use a battery just to re-level that pin. Try anyway, we'll see. I haven't done this before. There it is, re-leveled. Okay, so I've got those three pins back in because I did the undo button. And actually I can apply a bit more solder on each of those, not all at the same time, or it might fall out. Just to wet the solder. If you've been playing around a little bit, okay, it might dry that solder out because the solder has the flux in it. The flux chemically cleans, but the flux boils, burns up, and so that means that you can get a dry solder joint. So that's pretty good. So we've got those in place. Let's make the motor mechanism. We need 3 motors, 3 of these servo motors, and we're going to look at putting those together. So I might just move this out of the way. We'll get our first motor. We'll make this the central motor. And the top of the motor is the part next to the servo. Okay, this is the top. And on the top, this is where we get our little bits of acrylic. Actually, that's the wrong one. The top is this one. This little sharp, jagged one. Sorry if you've poked your fingers on that one. It is a bit sharp. Okay, so that should line up pretty nicely with that hole. Should be able to see right through there. And that's where our screw is going to go. Don't put the screw from the back on this one, because you'll end up chewing this wire out. And not good. So we will put the screw on the front. It's a little bit tight, but the plastic seems to wear it, which is good. I'm just going to hold that in place. This is probably the hardest part. It's fiddly. Okay, but you just need a screwdriver in there, and we just twist. And I'm going to put some pressure on that plastic because it's trying to bend and twist and get away from me. And so, oh, where is it? There it is. Oh, Tight. 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 Okay, it's going in. It's going in. Going in. Oh, off the shot. Sorry. That's really hurting. I think we should grip that in something to turn it. And mind you, if you put pliers on this, you might end up breaking it. But certainly that's tighter than I was expecting. I think it's because I got the right focus. It won't be so tight on yours. I'll adjust that. That's too tight, and that could crack anytime. Look at that, it didn't. Okay, it's in, but it's too tight, so I'll make the hole a bit bigger on yours. Okay, so that's the top section, and then we need the bottom section, and that's going to go on the same side as that one. Push that in, that should lock in there nicely. Okay, be a nice firm fit. And on this one, we can screw it in on the same side, or you can screw it in on the other side. Doesn't really matter on this because there's no wires to pinch when you do it. Just gonna screw it in the same way. Oh look, this one's going in a lot easier. And you'll find that because it's matched to the edge of that servo, it's actually easier. You can get more torque on it and it doesn't hurt your fingers as much, although you can see it's making an impression on mine. So that is the center servo. Yes, that is probably the hardest, most fiddly part of the project. Now, because, yeah, it is. Okay, so this one is going to go, let's just have a look at our circuit in here. Okay, this one is going to go in the middle, and we need our other servos to go like that. So this one points forwards and these ones point down, but the actual spline of the servo should be towards the back of the PicoRoach, not towards the front. Okay, so so they just sort of lock together like that. And once you've got one, it's easy to do the same with the other one, and you should have those two at the top there and pointing in that direction. And when they're pointing in that direction and you've got the three in that orientation, you place the power plant in the PicoRoach. Okay, so that should push down nicely on the PicoRoach, and it is a bit of a loose fit for those, but once we put the screws in for those servo motors, that will hold them in place. Now, like we did before, if we screw in from the top, we might chew up that wire. They do sort of pull upwards. That's a good thing about these servos, is they've got a little slot, so they've got the ability to go straight up or straight back, but still we don't want to chew up those wires. So no, I'll put them in from this side. Put them in. And what I'm going to do, this is flopping around here, I'm going to lock this off just so it's a bit firmer, and so that I can sort of let go of that for a moment. I'll get my trusty miniature screwdriver, pre-load the screwdriver. This is what I do to get it in place. Look at that, it's like magic. Bit of pressure on that to preload it, get it, line it up. I'll just turn it on the side to make it easier for me. Try and keep it in the shot, but making it fall off. Okay, so you'll see with that wire pulled up, it doesn't get in the way. But if you don't have one of these super fantastic miniature, oh, sorry about the head. If you don't have one of these super fantastic miniature screwdrivers, which is slipping because I'm going at an angle, try to screw them on squarely. Otherwise you might find that you end up stripping that out. Oh, okay, so that's nice and tight in there. That's one in place. Do the next one, so I'll just move these wires. Okay, once again. Oh, this is an old servo. I've grabbed an old servo here. It doesn't actually have that slot up the top. Ah, that's a bit of a pain. This is the problem. I'll show you that if I screw down in there, I'm certainly going to interfere with that cable and stuff it up. So I'm not going to. I'm going to turn it over. I've got one in place. Oh, I should unlock that. Alright, go. Unlock that. And some strain on that. Lock that back off. I actually have to move it this way now. There it is. You can see how handy these things are. They're pretty cool. If you want one of these, I sell them at the moment. $15. I might be running a special on these soon, depending on when you've watched this video. So we've got a shipment of these coming in at the moment from China with our new silicon lead soldering irons, which we've ordered twice now, and hopefully they'll provide the right ones this time. Sorry about those people that were waiting on silicon irons and found that we only had PVC irons because the manufacturer stuffed up, but that happens, doesn't it? People make mistakes, so yeah, just got to deal with them. Okay, I'm not getting much of a shot there. Pull it up. Okay, I'll look that. Okay, so I can screw from underneath. You can see that works quite well with these. And it avoids those cables altogether. Okay, so last one, these. I might swap that other one over magically. Put this one in. Just using my thumb there to support that and keep that without screwing down on my thumb. Okay, so this one is on the other side. Okay, so these are towards the butt end of the PicoRoach, not the head end. That head end's up the other end. Sorry for my terminology. Head, butt. Okay, now we're getting there. Now don't actually plug this on to that servo. Yeah, okay, we want to make sure when we power this up, okay, the microchip is going to tell that servo to go to its center position. When it's in its center position, then we put this on. Now we've done the servos at the back, we can clean up these wires a little bit by plugging them in. So we've got the yellow wire on each of the servos. That's the signal wire. And the signal wire is indicated by that white dot. So if you plug it in opposite, like that, with brown wire hooked up next to the white dot, it's not going to work. And obviously, I've just connected the center servo onto the side pin header, and that's not the way it should be either. So, so you have to make sure you get the correct servo there, correct servo, and we take that wire, that yellow wire, and that's the one that we plug on. Well, let me put this in a mounted holder so that it holds correctly, and we can see we can take the other yellow wire of the middle servo onto the back connector, and you'll see the white dot is just there. Okay, so we want the yellow wire on this side, not on this side. And last of all, we've got this servo yellow wire at the front next to the white dot. It's just pushed up hard against that servo. So there we go. So that's the 3 wires, and we can sort of twist them up or squash them down, just like that. Now, I get these servos manufactured specifically, so they have shorter wires. Normally these servos come with a wire that's 20 centimeters long. Now we've got all the servos in place and hooked up, we can start creating the legs. And to do the legs, we need 2 pivots. The back legs, we need 2 pivots, and we need 2 legs. This can be a bit fiddly as well, but it's the best way to be able to get those legs centered correctly. Now I'll just put one of those down, and I'll put one of these down. So you can see on the legs we've got a tall pin and a short pin, and what we need to do is we need to first of all put the first pivot on the tall pin. So if I slide that in, get the correct inner circles, we can slide that down, and it should line up level with the slot back here. Let's put the second leg on. So we have 2 legs on 1 pivot, and there's enough gap there to slide in the second pivot, and to just twist that around to line up those holes, and then we pull those apart, separate them, and you can see a gap down the center. So that gap down the center is for the circuit board. So we take that and we separate those. You can see I'm pulling those apart on that side so that it should slide on there. So 1 pivot above the circuit board, 1 below, and that just slides up nicely into place. Okay. Once that's in place, we've got some screws here. Now I do suggest if you don't want to poke yourself, put these in a vise and file down the point. It doesn't need the point, okay? Or if you've got a Dremel tool or something, or if you've got nail pincers, don't work so well, except on the very tip. You can cut those off. I wouldn't use side cutters. Pliers would work. Yeah, I'm not going to damage those. They're too hard. But get some pliers, trim those off, file them down, something like that. And we're going to use those screws with a screwdriver. So these are the larger screws. And we're going to put it in the hole just there. And when we get that right place, we just tighten that in. Screws in quite well. Just make sure you don't poke yourself on the other side. Okay, now I won't tighten that up yet. We still want some movement. And you'll see that those legs already move not too badly. So as we put in these screws, it's a bit self-centering. So that means that the screws will actually help to align the pivots, and when the pivots are aligned, those legs should move quite nicely, quite freely. So keep that on square. So that's going to create a bit of noise, but that's all right. So that's one of those legs, and we turn it around. That was the back leg that I did. We can still put that in our holder and do the other one. So essentially the same thing. We're going to get 2 pivots and 2 legs. On one of the pivots, put the first leg, slot it upwards. Second one, leg in through the pivot, and that slots upwards. Okay, so I'll put in the second pivot. Okay, pull apart. Make sure you can separate that gap at the back. Slide that on. Slide that up into place. Once that's in place, we can put in these screws. Okay, so there's the second leg in place. Okay, so putting on the switches at the front isn't too difficult. We can screw those in to mechanically mount those. First of all, I'll just show you how I'm holding that at the back there. So still using that PCB soldering shelf. Works quite nicely. Push it up as far as it goes. The micro switches we've got for the front are nice and easy to mount if we just put those underneath. It looks better with them underneath, I think. Could go above, but I'm putting mine underneath. And we want to make sure that the switch is poking outwards. So we just go up into the board and start to screw that in. Actually, I can do that for all 4 of those. Just get them started. Why not? Why not? Okay, and line that switch up, screw that in. A lot easier than pop rivets. Thanks to all the suggestions that came in for the PicoRoach and how to fix it, how to make it better, not fix it, but how to make it easier to assemble. Certainly I appreciate all the feedback I get from you guys as teachers. I'm not actually teaching in schools now, but you guys are in the field doing the hard yards, and your feedback is vital to me providing you with the best products and the most easy products. So there we go. Beep, 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 beep. Okay, so little feelers at the front. Now we haven't electrically connected those yet because you can see we've got all those little wires to solder. Okay, so we can put one of the wires down just enough that it's sticking through, bend it over so it holds in place, and really only only needs to stick through enough so that we can bend that over like so. There's another one. So poke it through, bend it over underneath, bend it over on top, and I'm just going to press that down like so. Doesn't matter if it's not particularly the neatest, and no, it doesn't have to get through those holes. It can just be bent on top like that. So that's two. Of course, we do need to solder these underneath here, and we also need to solder these on top. So let's spin it around. I'm going to put them all in on top and solder them. So you can see how much they're sticking through by. So easiest, oh look, I can see the hole now. So bend that over. So I just need 3 more wires. Bend that over. Now we will trim these back, so as long as they're not touching each other, that's fine. Like that is fine. Let's go and solder those off on top so they don't fall out. Make sure you've got adequate solder to cover the pad, so you get a good electrical connection. Once they're all soldered off on that side, we can trim these component leads down. They're no longer required to be so long. Okay, so that's the top there. One looks like it could use a bit more solder. If I solder it now, actually, it might fall back out, but we'll give it a go. There it goes, that's fine. Okay, so we'll spin that around. Now I've got 2 of those bent over, although it's moved out of place, so I just have to get in there and sort of hook it back over. So I want it to hook over and bend down. It looks a bit messy, but it's certainly the best way at the moment to mechanically fix those in. For these middle ones, we can actually bend those down. They're allowed to join together, just there. So I'm just going to wrap that over both of them, and I'll do that. These 2 outer ones, and I'll do that with that other middle one as well. So I'll just wrap those over, bend that down. So on the schematic, you would see that those 2 pins are connected in the circuit board anyway. So that's why I'm joining those. It's just easier to do. Bend this one down. This one down. Okay, I can trim up some of those later on. Let's solder them in place, and we're almost done. Don't need a whole lot of solder on those as long as it does connect to that switch. And I might just trim down these outer ones. You can see that sticking out there. Doesn't need to. I can pull it back out and then trim it. Outer one, and I'll trim the other side. That looks fine. We can see when we put an antenna on, it's that little slot is meant to come in there. So we actually have to bend these at that joint. So we just put a bit of pressure on both sides, bend them up like that, and you'll see that that fits in nicely. This could get messy. Bit of glue. Oh, here it goes. Bit of glue on this surface in here too. There it goes, and we'll stick and hold. There we go, too easy. Of course, the glue will make that antenna look a bit dull, but if you do it like this, upside down, then it's mainly on that underneath surface. So 2 dobs of glue is all I use there. And put those in, keep it nice and level, and away you go. 2 feelers on our PicoRoach. We're almost done. Let's I might be able to zoom out soon. I'll just show you. So with these levers here, or linkages, will move the front and back legs together. And let's get this front one in view. You can see that there's a little like pivot point down here, a little bit sticking out, and what we have to do is tip that on an angle a little bit, and that should clip in there. On top, there we go. And so once that's clipped in, then that's all you do to connect that linkage. And we can do the same at the back. Pushing that in, there we go. Got that in, so now we've got both legs. Now these linkages, be careful, one of them has a spline on the end. You can see it's got like little teeth in there. Don't stick your fingers together with glue. And one of them, the one with the smaller hole is the one that screws on to this hole over here. So we actually want to put that underneath, and we won't put that on the servo just yet. Remember, we have to center those. Yeah, so we need to put that underneath. We need to put that in there, like so. And we need to screw that in. And it only needs a couple of turns. We want that to be loose, and that screw will bind up nicely. If you do it up tight, you know, obviously that linkage isn't going to move, and you need it to move, because that is the part that has to stay parallel with the legs. Okay, the leg mechanisms. So, so that's one of them in place, and we can do the other one. I'll turn it this way. So that's, oh, I've tightened off the wrong thing. Oh yeah, okay, so we've got the other one there, ready to go on. So once again, we can clip this in place. Make sure that this middle hole is up towards the rear servos. And that should just push in like that. Same with this back one. push in like that. And certainly a lot easier than the metal linkages we used to have with wire, trying to fit those in. Okay, so screw in through that hole. That's the one that's sitting in loose. That is the smaller hole, remember, not the spline hole. And I'll turn that around a bit. And we can then line that up, screw that on. Okay, now while we're in that position, I'm going to plug in a 9-volt battery. So make sure it's a good 9-volt battery. Some of them don't have enough current to run servos, your cheaper ones. So Duracell works really well. Eveready doesn't. Energizer does. Okay, certainly Energizer lithium works fantastically. And Energizer lithium are like super expensive, but they're super light as well. So PicoRoach seems to get around faster. Okay, so we plug that in, and the on-off switch is over on this side, so I can just turn that on, and we should hear those servos moving. So we can put our finger there just to verify, okay, that those servos are moving. Yep, that's moving. What about this front one? Yep, that's certainly moving. Okay, so we've got all 3 servos moving, but if I just get that in position, if I turn it on and off, you'll hear that little movement of the servos. That is actually centering. So I'll show you again. If I turn it on, it centers, and then it goes into its little dancing pattern, stepping sequence. So turn it on, turn it off straight away, and we know we've got those legs centered. Now, I'm going to have to take this out of the... Okay, so those are centered. So what we want to do now is we want to make sure that this leg goes on as much as possible perpendicular to that body, and it should make each of the legs perpendicular. Okay, when it goes on, get that in place, put some pressure at the back of the servo, otherwise you might pop a servo apart. Okay, but that just presses on. It's a press fit. Well, actually, we can test that one leg. See that it's working. It is working. Awesome. So let's center those servos again. Okay, and they are centered. This one's going to be a bit tighter, but it should be fine still. So that should just be a press fit on there. So we can push down. That'll lock on. Now, I do warn you that if you push down and you're not supporting the back, these servos can pop open. Okay, so you always need pressure on the back. If they pop open, the gears can jam, and then you're going to break one of the plastic gears. Okay, so it should pop on nicely, and when you have it in place, it should work nicely, and there should be no reason for that to come off again. Okay, it is a press fit. If you do pull it off again, then you might also break that motor depending on how rough you are. Okay, so you do have to be careful with that. Once it's together, leave it. Okay, so last of all, the servo at the front, we can center that one, and when it's centered, once again we can press fit that acrylic on, and we just want to get that nice and level, so you can see that, and we'll put some pressure on the back of that servo, and we'll push it on. There we go, that one wasn't too hard, and we're almost there. So you can see all the legs have come together on that. Antenna in place. What are we missing? We're missing the rubber bands for the feet. So you'll get 4 rubber bands one for each of the feet, and this provides the traction so that the PicoRoach can walk along the ground. Now, these are green, just to show you how it works, okay? Because if I use a different color, it may not show up so well. So I'm just going to put that in the middle hook, or maybe actually on the bottom hook. On the bottom hook, get it underneath that foot, twist it, and then move it back up. Once it's twisted, move it back up and put it on the next hook. Okay, like that. So that's how we get the little foot traction there to give us some grip. And we don't really want it to cross over at the bottom. So what we can do is we can try and lay those side by side like that. They should fit into that gap nicely, so you get those two little bits of rubber band. And yes, this is a loom band, so if it does wear out, like these ones are wearing out a bit because I've used these before, if the loom band does wear out, then you just need to get some more loom bands. Okay, so but a nice easy solution to make those feet stick. So do that for each of the legs through the first hook, up and over, twist, maybe pinch it once you've twisted it and put it on the second hook. Okay, fit those in side by side in the little groove. Just pop those out and pop them back in, just so that they sit in there nicely, and they shouldn't come out too easily. Okay, so so that's what we do. Another one. Up there. That's in nicely. And last of all, the back. So in the first tooth, wrap it over, and in the second tooth, or the third tooth, depending on how tight you want those. The tighter they are, actually, it'll hold it on better, but you may not get as much traction in the end if those bands are a bit too thin. Okay, so so that's how to, popped it back out. That's how to get those rubber bands in the right place on the feet, and you should find that that actually has quite good traction when you put it down on a flat surface. So we're almost there. One thing with this battery, we do need to mount that in place. So I'm actually going to wrap it around. I'll disconnect the battery. I'm going to wrap it around this way. So if you haven't shortened it, like I haven't, I'm going to wrap it around like so. So I'll wrap it underneath and back over the top. And the heat on that shouldn't be enough to melt the wires. So we can go over the top there, and that should be about the right length so that we can sit that in place. We need to mount that battery underneath. So we'll turn that over. If I do it that way, that's going to interfere with the leg. So it's best to do it the other way. So we should be able to set that battery up against the leg up there and press it on nice and firmly. Make sure it doesn't interfere with that leg. And there we have it, our PicoRoach. There's the PicoRoach, pretty much done there, and we can turn it on and watch it go. PicoRoach. Oh, go backwards, PicoRoach. Both together. Turn around. There he goes. Oh, he's falling off. Haha. There it goes in a different direction and it hits the antenna. Okay, so that's how to construct the PicoRoach. I hope you've had fun. There is another video on how to program the PicoRoach with the PicoFlow Alpha software if you would like to get some programming experience. Thanks for watching.